following data sets. Data set D1 contains all the values equal to 5. D2 is like that, 3, 2, 5, 6, 7. We can see that the mean for each of the data set is 5. Here mean is not able to discriminate two data sets, which is average deviation of the data elements in the data set. For example, if mu is the mean, mu minus x1 will be the deviation of first point from the mean of the data set. If we add all these deviations like this, mu minus x2 plus mu minus x3 plus mu minus x4 plus mu minus x5, we are squaring these quantities because some quantities may be negative. For example, if we consider the last value of the data set, then 5 minus 7, this value will become negative. So for avoiding these negative values, we are squaring these deviations and dividing these values by total number of values minus 1. This will be called the variance. Which is denoted by sigma square. Sigma is called standard deviation. Clearly we can see that sigma square for dataset D1 is 0. All these quantities will be 0. Mu is 5, x1 is 5, mu is 5, x2 is 5. All values will become 0. Hence the variance will also be 0. We are dividing these values by n minus 1 because at least one of these values will be 0 or very close to 0. For example, in dataset D2, the deviation mu minus x3 will be 0. That's why we are dividing this squared sum by n minus 1. We can also write sigma mu minus xi squared divided by n minus 1. Suppose this data set contains heights of 7 students. If from this list I want to know the probability that a randomly chosen students from this data set has height 175, then the probability of this event will be 8 over 39, because 39 is the total number of students and I am interested in this value, and by this that's why the probability will be given by 8 over 39. But suppose the data set given is a sample data set of a large population of maybe 100 students. Then how can we predict height of randomly chosen student from out of those 100? Gaussian distribution tells the distribution of population over a data set. Now the question is like this: what is the probability that a randomly chosen student from the whole population of 100 students, a randomly chosen student from the whole population which is 100 has height 173 centimeter, and out of these 100 students, this data set of 39 students has been drawn. Now if we consider the data set, the probability comes out to be 0. This is very unlikely that 173 occurs in the drawn data set. Now this distribution has following property: the population covered in this particular area, from mu minus sigma to mu plus sigma, the amount of population is 68%. It means 68% of the total population falls in this area of the curve, and this area from mu minus 2 sigma to mu plus 2 sigma covers the 95% of the population, and mu minus 3 sigma to mu plus 3 sigma, this complete area covers 99.7% of the total population. Rest 0.3% population is covered under this area of the curve.